Digital Systems, where we decode how artificial intelligence is transforming structural engineering and reshaping global real estate, giving you the intelligence to stay ahead of one of the fastest moving shifts in the built environment. In this video, we're going deep on what's happening right now inside engineering firms, on construction sites, and in the software labs that are quietly automating tasks that took licensed engineers years of training to master. By the end, you'll know exactly which engineering tasks AI is already outperforming humans at, which roles are at genuine risk, and most importantly, what this means for real estate developers, investors, and the buildings we all inhabit. Stay with me, because this is moving faster than most people realize. Before we can understand what AI is replacing, we need to understand what structural engineers actually do, because the public perception is often wrong. Structural engineering is not about making buildings look good. It's about making sure they don't fall down. A structural engineer's core workflow breaks into 5 major areas. First, load analysis. Every building must withstand dead loads, the weight of its own materials, plus live loads from occupants, furniture, and equipment, plus environmental loads from wind, seismic activity, and snow. Engineers calculate how forces move through every single element of a structure, from the roof to the foundations. Second, material specification. Which grade of steel, what concrete mix design, what tensile strength is required at this connection? These decisions have enormous consequences for cost, durability, and safety. Third, building code compliance. Every structure must meet national and local codes, the International Building Code in the US, Eurocode in Europe, local standards everywhere else. Compliance checking is meticulous, time-consuming, and has zero margin for error. Fourth, structural modeling. Building and running finite element analysis, models that simulate how a structure behaves under different loading scenarios. This is where the engineering software does the heavy computational lifting. Fifth, inspections and quality assurance. Visiting construction sites, reviewing contractor work, signing off on structural adequacy. The human judgment layer in the field. Now, which of these 5 areas is AI attacking first? And how quickly is it moving? Let's talk about specific tools, because this is where the reality becomes impossible to ignore. Autodesk has integrated machine learning directly into its structural analysis suite. The system can now take an architectural model, automatically generate structural load paths, run preliminary sizing for beams and columns, and flag code non-compliance, all before a human engineer has even opened the file for review. Victor is a Norwegian platform that allows firms to build custom engineering applications, essentially digitizing their entire structural design workflow into automated pipelines. What used to take a graduate engineer 3 days can now run in an automated loop in under an hour. The economic implications of that shift are enormous. Hyper is a cloud-based generative design platform that allows structural and architectural systems to be explored simultaneously using computational optimization. Feed it your constraints, budget, site dimensions, program requirements, and it generates hundreds of structurally valid solutions, ranked by efficiency. Solutions a human team would never have time to explore. Speckle connects software platforms in real time, Revit, ETABS, Rhino, SAP 2000. Allowing real-time data synchronization and AI-assisted coordination. Shear Engineer has introduced AI-powered post-processing that interprets FAR results and generates automatic compliance reports with specific code references attached. Here is the critical insight. These tools are not replacing structural engineers at the top. They are systematically eliminating the junior and mid-level tasks that make up the majority of billable hours in every engineering firm. A task that required a junior engineer at $90 an hour for 3 full days now costs a fraction of a software license fee. The economics are brutal and unavoidable. Let me give you 3 real-world examples of what this looks like in practice. Case 1. ARUP, one of the world's largest engineering consultancies, has been piloting AI-assisted structural design workflows across multiple international projects. In their public communications, they have acknowledged that AI tools are allowing their teams to explore 10 times the number of structural options in the same timeframe, effectively compressing weeks of analysis into days, while the number of staff hours per project has been dramatically reduced for preliminary design phases. Case 2. Buro Happold, the international engineering firm, has integrated automated code compliance checking into their Revit workflows. Their engineers no longer manually cross-reference building regulations for every element. AI does it continuously in the background, flagging violations in real time. What used to require a dedicated compliance review stage consuming days per project is now continuous and near instant. Case 3, Thornton Tomasetti, one of the premier structural engineering firms in North America, developed Core Studio, their own computational design and AI platform. They have openly described it as their competitive differentiator, allowing their engineers to run generative structural optimization for complex projects that would be impossible to explore manually. The result? More innovative structures, fewer engineering hours per project, and a competitive advantage that smaller firms without these tools simply cannot match. So what does this mean for jobs, and what does it mean for real estate? On jobs, the structural engineering roles most at risk are exactly the ones you would expect. Junior calculation engineers, routine code compliance reviewers, and basic load analysts. The World Economic Forum's Future of Jobs report consistently identifies repetitive analytical tasks as the highest AI displacement risk. What's growing? AI-augmented senior engineers who can direct and validate AI output. Computational design specialists. Engineering AI developers who build the tools that others use. The profession is bifurcating. Those who master AI will be more valuable than ever. Those who don't will face increasing competition from software itself. For real estate, the implications are unambiguously positive for developers and investors. Lower structural engineering costs mean reduced total construction budgets. Faster design cycles mean shorter time to market for development projects. AI-optimized structural systems mean less material waste, with structural steel and concrete accounting for significant portions of both construction cost and carbon footprint. AI-driven optimization delivers real and measurable financial returns. In some markets, AI-optimized structural design is already being cited in due diligence reports and used to justify lower contingency reserves in project financial models. The buildings being designed today with AI tools are, structurally, more efficient than anything designed manually, and that efficiency translates directly into asset value and investor returns. If this kind of intelligence, the intersection of AI, structural engineering, and global real estate, is exactly what you have been looking for, then ALFA Digital Systems is your channel. Hit subscribe, turn on the notification bell, and book an appointment with us at worksbyalexander.com, and every single week you will get exactly this, data-driven, no-fluff analysis of the technologies reshaping the built world. In the next video, we are covering something even more alarming, AI systems that predicted building collapses before they happened. Real case studies, real sensor data, real structural failures that AI caught before human engineers did. You do not want to miss it. Until next time, stay informed, stay ahead. This is ALFA Digital Systems.